Features of products from twisted yarn obtained from fibrous waste in modern technologies. Abstract. The article presents the results of a study of the properties of curved fibrous waste. Standards determined the availability of fibers of acceptable length for the production of yarn from used fibers. Cleaning options are available depending on the type of waste in different plants. A spinning plan is developed and the test results of the physico-mechanical properties of yarn samples are analyzed. The possibility of obtaining medium-density yarn with attachment in a mixture of spins of the group directly under conditions of maximum purification and high uniformity of mixing of the components is shown. Keywords: yarn, spinning, linear density, quality, spinning method, rotor spinning machine. At present, improving the quality of textile products, in particular yarn from the same raw materials, is an urgent task to help increase the export opportunities of relevant market demand products. The production of high-quality competitive products in the world market, based on the use of new, more advanced technologies, is the most important task of the textile industry. The quality of textile products depends largely on the uniformity, purity, and strength of the yarn. Improving the quality of textile products can be achieved through the introduction and use of modern equipment based on advanced technological principles. 9. The efficiency of spinning production largely depends on the rational use of raw materials, which to a greater extent affects the cost of yarn. The release of fibrous waste from textile fiber processing is known in spinning machines and engravers. Direct waste is of great importance among them, since it allows to save high-quality fiber and reduce the cost of production. 9. In production conditions, to produce 8 fabric, reinforced yarn was used as weft, and linear density 25 tex yarn was used as the main threads. Table 1. Physics mechanical indicators of harsh tissue are given. Linear density, in T-text width fabrics cm density per 10 cm. Gap load in kg elongation at percent fabric weight in g. The basis weft the basis weft the basis weft the basis weft the basis weft. The table shows that the properties of the harsh fabrics of I-twisted yarn meet the requirements of GOST, and the properties of the fabric from reinforced yarn are higher than these requirements. For an hour, the breakage of the yarn on the looms was checked. There are 10 cliffs in the reinforced yarn of all. 6 of them are in the base, and 4 in the duck, and in twisted yarn there are only 15 clippings, 7 at the base of 8 in the duck. The productivity of looms is 3.54 m/hour of twisted yarn 3.01 m/hour. From the indicators it is seen that the use of reinforced yarn increases the quality indicators of the fabric. The prepared harsh fabrics were rewound onto a roll, and the LBOX firm Kyoto bleaching machines were filled with where they bleached, steamed, washed and dried the fabric. We checked the capillarity and whiteness of the fabric leaving the machine. Table 1. Results are shown. Fabric's capillarity, in mm. White, in percent. HB50 Vis 50 72 78. HB50 PF 50 70 74. US 33.333 PF 33.333 Vis 33,333 72 85. HB-67 Vis 33 64 71. According to the technical conditions 60 to 70 70 to 78. The table shows that laboratory tests for all the yield of nap even at one transition, and the serial fabric samples meet the requirements of technical conditions, and was released repeatedly, because in the first combing, the capillarity is higher than standard. Pile of fabric came out unsatisfactorily. If you change to improve the properties of the tissue, it was parameters of the machines, the material will deteriorate. Emulsified using an emulsifying unit. For the prepared materials shown in figure N. After emulsification, tissue samples are refueled 1.2.3.4. Prepared the following ink composition in the on-pile machines. Samples of 3 variants of the fabric printing shop in Table 3 obtained from reinforced yarn gave a satisfactory result in Table 3. It is proposed that the following ink composition is prepared in the print shop. 1 black reagent 2/116 kg. 2 active yellow 2/112 kg. 3 Cibicrana olive 2/116 kg. 4 Zarin Ali 2/116 kg. Samples of the fabrics obtained from the printing shop are shown in Fig 1, 2, 3, 4. Figure 3. Finished fabric from reinforced yarn, Colopolysphere waste. Figure 4. Finished fabric from twisted yarn of cotton viscose fibers in production. Figure 2. Finished fabric from reinforced yarn of cotton polyester waste. Table 3. Physico-mechanical properties of finished fabrics are given. Sample average shrinkage. Width Vs, with edges massa V1M2. The number of threads per 100 mm bursting load strips 50x200 elongation at break. By basis of biduct by basis of biduct by basis of biduct by basis of biduct. 86,7 86,5 85,0 91, 6207, 1 225 214, 8 163, 5 cotton and viscose waste 320 158 54 41 14 42 332 152 59 62 48 cotton viscose and polyester waste 331 157 55 41 12 47 cotton viscose fibers in production 308 158 44 32 10 35, 54, 66, 04, 05, 04, 04, 73, 1. From the table it is visible that the physico-mechanical properties of the prepared fabric from reinforced yarn are inferior to the series of it. Conclusions 1. In order to study the consumer properties of yarn, in Namanan Ao Joyi made fabric samples of HB/Vis, HB/PF, HB/Vis/PF. 2. Studies of the physical and mechanical properties of harsh and finished fabrics showed that the fabrics meet the requirements of the standard and even surpass these requirements in some indicators. 3. The economic effect of the introduction of cotton yarn and their products, i.e. fabric, will be 154,965, 5,871 U. Total 1998 prices by reducing the cost of raw materials, increasing. 8. Khaidarov, and T. Ismailov effect of torsion on the mechanical properties of reinforced yarn. International Journal of Engineering Research and Technology, IJERT, Volume 9 Issue 02, February 2020. 860 to 862 p.